Okay, so we were saying that any of the commercial CFD packages will include the three main elements, but they can be presented in variable forms. So for example, if we consider ANSYS, okay, in ANSYS workbench, we will work with first with design modeler. Design modeler will be the part where you will create your geometry, okay, and then you will, after you create your geometry, you will mesh it. You have a step just to do meshing. So you divide it into small control volumes. You do some strategies to enhance the quality. We'll talk about all of these. So design, modeler, and meshing work will constitute your preprocessor. Then you move to using the solver. It's called Fluent. So when we say ANSYS Fluent, we refer to the solver used. So it will represent several algorithms and methods of discretization of your equations that are offered by Fluent, and you can select the ones that are convenient for your application. And here also you will set, for example, if you have a transient or steady application, you will set the time step, you will set the boundary conditions, you will set the initial conditions, and then you will run your calculation. And at the end, when your solution is converged, you can stop the calculation and you can go to CFD post, which represents the post processor, where you can explore the results and take pictures and contours that will illustrate the physics of your problem. Now, to see it in a more practical way, okay, we'll see after how we can open ANSYS and how we go through all of these steps. Okay, now in this course material, we'll also introduce the different methods of transforming our differential equations into numerical ones. Okay, so we have three basic methods to write our numerical equations in computational fluid dynamics. The first method is the finite difference method that we'll go over. We have also the finite element method, and we have other methods called spectral methods. Now, the most used is the finite volume method, which is a special case of the finite difference method, and it is implemented to ANSYS Fluent, and this is a very popular and used method in CFD packages softwares. So in the course material, we'll develop some of these techniques, and in the lab, we will apply them on engineering applications. Now, let us introduce you to ANSYS Fluent. Were you able to download ANSYS already?
دكتور احنا هنستعمل انسس بالصف او باللاب؟
باثنين، لانه حتى بالصف في مطلوب بروجكت، بس يلي عم ياخده لاب مفروض يكون البروجكت مور ادفانسد. اوكي، بس بوث
دكتور هو ذاته الانسس هو ذاته اللي مستعمله بالفاينانت اليمنت هو ذاته ايه؟
هلا مبدئيا يمكن بالفاينايت element شو استعملتوا انتوا؟ ورك بنش، اسمه ورك بنش، انسس ورك بنش.
ايه بس ستراكشر
هو فيه كذا لايبرري.
ما اصلا الانسس ورك بنش بس تفتحه في عندك عده possibility، وحده منهم بتنقي فلوينت، في عندك عده other applications، يعني بيكون في وحدين تانيين للفاينايت element.
اوكي
بس اذا عندكم هلا حفرجيكم الايكون تبعه، بس تفتحوه شو بيطلع لكم window and how you select fluent. You might have it already. If not, please already على جروب السي اف دي لاب حطوا several links. حدا قدر جربهم تينزل انسس or not yet؟
فينا نستعمله على اللاب.
انا نزلته بس هلا اليوم بدي اعمل له ران.
اوكي، so please جربوا to download it within this week، لانه حنبلش. يعني انتم شفتوا باللاب وبالكورس في بالسيلابس محطوط انه for the first week for the first 2-3 weeks we should introduce you to how to use the software and how to draw a geometry and how to mesh it and do the run. Okay, وحيكون مثل ما قلت لكم في project for the course and for the lab. هلا يلي عم ياخذوا lab حيكون little bit more advanced، يعني بدهم يكون البروجكت more developed. يلي بس عم ياخذ الكورس I will tell you يعني what will be the difference, but both should know how to create a geometry, how to mesh it, how to put the setup, and how to run the simulation. Okay, so now ANSYS is an engineering simulation software developed in the United States, and it's one of its most significant product is ANSYS CFD, which is a CFD program that is widely used in the world. Now, ANSYS Fluent is one of the most popular commercial CFD software packages, and we will use it to solve several engineering problems in this course. Now, ANSYS Fluent solver is based on the finite volume method, and in the course we will develop the theory of this method, and it will be used in the lab for practical engineering problems. So the mesh part will consist on discretizing the domain into a finite number of control volumes, and then we'll apply the general conservation equation of mass, momentum, energy, and species to be solved in this set of control volume. So the idea is that all equations that we have already presented, continuity, Navier-Stokes, energy, can be solved by transforming them from differential relations to numerical relations. And we will select the appropriate schemes in order to solve in each control volume. And when you divide your system into small control volume in the mesh part, then you will have a certain number of cells. In each cell, you will solve for your equations, and this will allow you to compute, for example, what will be the temperature for this cell, what will be the velocity of the flow through this cell, what will be the concentration if you have, let's say, species within the spreading in your domain. You can use several methods to calculate the concentration of these species. We'll develop together methods. We'll see that you have what we call the Eulerian method, which will consist on writing a concentration equation and solving for it. You have also the Lagrangian approach, which will track several particles within the space and try to convert trajectory of particle information into concentration. So we'll go over these and learn how to compute the temperature, velocity, concentration profiles within a space. Now, the different steps that are used to solve a problem using ANSYS Fluent are first the pre-analysis. So before starting, we should do an analysis of our problem to see what are the simplifications that we can do that can facilitate the computation. And then when we decide on the simplifications that can be done, so for example, as I told you, in a certain space, some object might not affect a lot the distribution of particles or the distribution of airflow, so you can ignore their presence. If not, you should take everything in the room, depending if they affect really the behavior or not. Once you decide on the elements that will have the dominant effect on your flow behavior and particle behavior, you can draw the geometry. And after this, you will mesh it, you will divide it into control volume, you will input your boundary conditions, and you will select the convenient tools used to solve your numerical equations. Then you can run this solution. And finally, you have the step of verification and validation. As I told you before, any CFD model should be verified and validated. This is why what we do in general when we develop a CFD model, we try to compare its results. So we try to first simulate something already done. Yeah, we have already data on it, or already we are doing experiment to compare the result of the model and the experiments. Then we compare results. If we have close values around 5 to 10% agreement, then we can say it's fine. The CFD model is working well, and then we can use it to do a parametric study and to study the effect of different parameters on our problem. Now, for ANSYS Workbench is a graphical user interface that will allow you to use all the required tools from a single place. So you can access then a preprocessor, a solver, and a post-processor from ANSYS Workbench, and you can control the workflow between variable tools through this workbench. To illustrate this, okay, you have the following slides, which will show you the windows that will appear when you open ANSYS Workbench. So when you open ANSYS Workbench, you will see this. You have this icon, okay? You have the yellow color with a reversed V if you want. So this is a symbol of ANSYS Workbench. And you will have, your window will have at the left part of it, a toolbox presenting several possibilities that you can select, okay? Which the one we'll use is fluid flow fluent. So you should have fluid flow fluent to select. When you select this icon, then you will have at the right a window which will appear, and it will be divided into 5 parts, okay? The first one is geometry. In this part, you will draw the geometry of your problem. Once you are done, you will move to the step of mesh. So you will double click on mesh. Then in mesh, you have several techniques that can be used to divide your system into small control volumes. You can use strategies to enhance, to refine your mesh in some locations. We'll learn what are the critical locations where we should refine the mesh, how we can test the quality of the mesh if it's good or not, what are the different criteria that will be used to determine the quality of the mesh, like what we call skewness, orthogonal quality, aspect ratio. So you'll be familiar with these terms. Once done, okay, in general, this step is the most difficult because sometimes you need to reiterate. After doing the solution, if you find that we have divergence, or if you find your physical result not very logic or not comparable with real results, you should go back to your mesh and try to enhance its quality and then go back to your solution. So this process can be iterative, and you might need to repeat several times to reach a satisfying final mesh. Okay.
هلا سؤال على سيرته هيدي بالمش على انسس بس كنا بالفاينايت في عنا limitation كمان الكيس هاني
limitation about what؟
عن عدد الماتش اللي فينا نحطها.
هلا look in general حسب اذا بتعمل داونلود للفيرجن الاساسيه المفروض ما يكون في ليميت. هلا اذا فور كرانك فيرجن مزبوط بيحطوا لك ليميت على النمبر اوف elements. هلا نحن حنجرب البروجكتس حنعملهم حيكونوا انه بطريقه انه النمبر اوف allowable control volumes is enough for you to have good results. اوكي هلا بس يكون البروبلم كثير complex، يعني let's say you are investigating a very large space وفي بقلبه كتير objects, you will need a very large number of elements. ساعتها بيكون فيها limitation. يعني limitation هي due للversion that you are downloading إذا crack أو لا، أو إذا الأوريجينال أو لا. بهيدا المعنى في limitation. بس أنت عادة you don't have a limit. You can increase the number of elements as much as you want. هلا أكيد بيكون بدك storage capacity أعلى، يعني الكمبيوتر كل ما زاد number of elements you need larger storage تيقدر يحفظ information. So it depends on your computer capacity and on the version you download it. Okay. بس مبدئيا نحن البروبلمز حنعملهم the limitation is enough، يعني ما حتعوز اكثر مبدئيا. اوكي
دكتور فيهم يكونوا انا مش كثير كومبلكس كرمال اللابتوب يتحملهم تيحلها.
هلا في اكيد نحن البروبلمز حاعطيكم هن بروبلمز بينعملوا during the required time وما بيكونوا شيء كثير كومبلكس اكيد. يعني مثلا في problems بياخد 1 week simulation وفي problem بيكونوا more simplified بياخد 1 hour يمكن to give you results. وحتى في منهم اسرع بكتير. So it depends on your problem. اكيد انا حاعطيكم projects ما يطلبوا كتير computational time.
يس، واذا كانوا كومبلكس بتقولي لنا انه ننزل على الجامعه بنعمله على اللابتوب بالجامعه
هلا
احسن
اذا
ما نعمله
كانوا
على اللابتوب
كومبلكس
بيروح.
مش ضروري. اذا بدك كومبلكس فيك يكون مثلا شيء ما بده هالقد كومبيوتيشن بس بدك تعمل عده رانز وبدك تعمل اناليسز اكثر بهالمينينج كومبلكس. يعني مش ضروري قصه انه ما يتحملوا الكمبيوتر تيكون كومبلكس.
اوكي
يعني
دكتور
في CFD حنشتغل شيء على الهيت او لا؟
فينا نشتغل على اللي بدكم اياه. يعني في عده ابلكيشن هي اكيد. يعني احنا اول شيء بالكورس حنكتب الايكويشنز including heat equation, including Newton law, including continuity وحنشوف كيف بنحله numerically.
انه في بارت هيت انه حيكون بالبروجرام هالسنه
اكيد اكيد في بارت هيت.
اوكي ثانك يو.
دكتور نحن الجيومتري تبع السيستم اللي انا عندي هو برسمه على انسس ولا على سوفت وير ثاني؟
هلا فيك ترسم على سوفت وير ثاني وتعمل امبورت للجيومتري بس ما كثير بنصحكم فيها لانه اوقات تعمل مشاكل. يعني بس يصير في ترانزيشن من مطرح للثاني اوقات بالمش بيخربط شوي بيعطيك زونز المش كواليتي مش كتير منيحه فيهم. بصير بدك تو جو باك اند فورث يعني ترجع تظبط جيومتري هونيك وترجع. فاحسن اذا بتعملها اوريدي بما انه عندك الاوبشن اوف drawing the geometry in Fluent it's better to do it in Fluent.
اوكي ديل. اوكي
طيب now once we are done with our mesh, as we said, we move to the setup where we implement the different boundary conditions, the initial state, the methods we want to use to solve for our problem, and we run the simulation. هلا هون بالsolution هو الrun part. يعني حتعملوا run and you will observe the residuals. حنشوف شو يعني residuals بالcourse material. You will observe the variation of residuals. مفروض يوطوا ويقربوا على zero. Okay. Now in case you observe divergence يعني عم بيطلعوا ال residuals. Okay. ساعتها this means that your run is not going very well. هلا sometimes ب some situations بيعلوا أول شيء بيرجعوا بيوطوا. So we should wait some time. بس إذا ضلوا يعلوا بعدين this means that we can have divergence and we should try to enhance the mesh quality to have a better solution. Okay. So sometimes في كتير strategies to reduce divergence. أوقات إذا عندي study application مثلا ببلشها transient تيكون في smooth variation أول شيء وبرجع بحولها لstudy. Another strategy is to use what we call under relaxation factor. We will see in the course material كمان what is under relaxation and we'll see how to implement it in Fluent. Okay. And once done with once I have a converged solution, I can explore the results here. فيني نطلع plots اللي بدي اياهم. فيني نطلع numbers. So I can compute, for example, average temperature in a certain plane. I can create a plane, find what is the average temperature, velocity in this plane, for example. فيني شوف profile. So I can do a lot of things بالresult section. Okay, so this is in overall the different steps that I will use in ANSYS Fluent. Now, so as we said, here we are summarizing the different steps for simulation. So as we said, in the first step, we'll do the pre-analysis. So in the pre-analysis, we want to solve a real-world engineering problem numerically using ANSYS Fluent. Then we need boundary condition. So what we will do, we will observe the real physical situation, and we will collect data to represent the actual case. You will also obtain corresponding theoretical or experimental result to compare it with your simulation. So this is for the validation purpose. These steps are important, especially to obtain correct boundary condition. The boundary conditions affect a lot your results. يعني مفروض تعطوا boundary conditions that are real and that represent our real case that we are studying. So for example, if you want to simulate airflow over the wing of an airplane, you have to know the range of speed for that wing. يعني لازم أعرف إنه أنا when I have a flight, what is the range of speeds that will be for which my wing will be exposed. تعرف على أي أساس بدي أعمل simulation على أي range of velocities. Okay. You will also look for previous experimental or numerical results and relevant theories تقدر أعمل comparison between the results I obtain and literature or experimental data, because this will help me to make sure that my CFD is giving me physical results. Now, once I am done with the pre-analysis step, I can start to perform my work. So I can start with the geometry. So the first step will be to make the geometry. You can use ANSYS, design modeler software, or as I told you, you can import the geometry. You can use AutoCAD, you can use Inventor, you can use SolidWorks, but I don't advise you to do so. So it's better to draw your geometry in ANSYS, because if you need to change anything, you can directly do it. No need to go to the other softwares and import it again, etc. Okay. Now, for the meshing part, this is one of the most important steps for your simulation. It will consist on dividing your space into several control volumes. You will decide here on the type of control volumes you will use. And for example, if you have, whenever you have curves in your system, a lot of curves, the orthogonal mesh will not work very well. يعني تخيلوا انتم to be able to trap a curvature تيجوا تحطوا orthogonal elements حيقدر يلقط مظبوط الكيرفز. So then you need to use what we call tetrahedral elements اللي بيكون عندهم مثل face triangular. This will give you more flexibility in the meshing process. Okay, so we'll talk about these strategies when we go to meshing techniques. And the result of your simulation will depend a lot on the mesh quality. If you have a bad mesh quality, you can expect divergence of your results. This is why the first thing to think about when you observe divergence is to go back to your mesh and try to enhance it. Okay, low mesh quality can produce poor simulation result and even divergence, which is not desired, of course. Now, in the physical setup, we will use the solver of ANSYS. So we will give inputs, boundary conditions. We will select what are the physics involved in it. For example, as I told you, let's say you have a heat transfer application. Maybe conduction and convection are important, but radiation is not. So no need to put the radiation modeling on. So here you can select what are the models that you want to put on, what are the models that you don't want to use. Okay. You will select what are the material involved, what are their properties. So in this case, you will implement everything needed to conduct your simulation. Now, how to start ANSYS. So when you download ANSYS, all you have to do is to click on the icon of ANSYS Workbench. And then, as I told you, you will have a window that will open. And in the left part, you will select for Fluent icon. And once you select it, you will observe this window here. This tree will show you all steps you need to complete your simulation, from geometry to observation of results. So hopefully for this week, please try to have your ANSYS downloaded on your computer. So then we can start with some practical issues, how to use ANSYS, how to draw the geometry, how to perform a mesh and setup. And we'll start with a small example that will allow you to see how to perform these different steps and how to obtain results that can be where we can perform analysis and where we can see the physics of the problems we are studying. Okay. Any questions?
Tomorrow أو next week هنبلش بأنسيس دكتور.
Yes, next week, inshallah, we'll start with answers because in the syllabus division, we should start with an example to show you the different steps of CFD. And then we'll start with the theory in parallel, okay?
اوكي deal.
Any question on this?
دكتور بكرة عنا صف 5.
Yes, بكرة عنا صف مبدئيا إن شاء الله.
أوكي.
Okay.
ميرسي دكتور، يعطيك
Welcome.
العافية.
Welcome. Yeah, let's see you
Bye,
next
Dr.
time.
Thank you,
Bye.
doctor.
Bye.
Bye.
Thank you, doctor. Bye, doctor.